Good morning, my dear students. In this particular video presentation, we will continue with the remaining problems on exercise 7.3 on integration from NCERT textbook. The 14th problem in that exercise, it goes like this: integral cos x minus sin x dx divided by 1 plus sin 2x can be written as cos x minus sin x, let it be as it is, divided by, I can very well write this as sin square x plus cos square x plus 2 sin x cos x. This one can be written like this. Now numerator can be written as d of sin x plus cos x. Denominator can be written as sin x plus cos x whole square using a plus b whole square formula. Think over the numerator. Derivative sin x is cos x is minus sin x. This can be written as dt by t square, where my t is sin x plus cos x, can be written as t power minus 2 dt, which is t power minus 1 by minus 1 plus c, which is minus 1 by sin x plus cos x plus c. Let me repeat the whole process. Integral cos x minus sin x dx by 1 plus sin 2x is the question given to you. I write the numerator as it is. Denominator 1 can be written as sin square x plus cos square x. Sin 2x can be written as 2 sin x cos x. This can be written as sin x plus cos x the whole square. Sin square x plus cos square plus 2 sin x cos, using your a plus b whole square formula. I have a clear observation. Derivative sin x is cos x is minus sin x. Whenever I write d of, I should multiply dx also. I already told you in most of the videos earlier. Now whatever is written as d of should be my substitution. Therefore, so to form dt by t square, where t is sin x plus cos x. T square in the denominator can be taken to the numerator. Integral t power minus 2 dt. Using the formula, integral x power n dx is x power n plus 1 by n plus 1, becomes t power minus 1 by minus 1 plus c. Minus 1 by sin x plus cos x plus c is the final answer. That is the final answer. Now for the 15th problem, he says tan cube 2x. It is tan cube 2x into secant 2x dx. I will write this as tan square 2x into secant 2x tan 2x dx. This can be written as secant square 2x minus 1, and I observe derivative secant 2x is 2 secant 2x tan 2x dx. Therefore multiply and divide by 2 here. This can be written as half integral secant square 2x minus 1 into d of secant 2x. d of secant 2x is secant 2x tan 2x into 2 into dx. Wherever I have d of, I should multiply dx. Remember carefully. If it is in terms of x, dx is in terms of t, dt. If it is in terms of y, dy, multiply dy also. Whatever is given as d of will be my substitution. Is to the form t square minus 1 dt, where my t is secant 2x. Therefore this becomes t cube by 6 minus half t plus c, which is anyway secant cube 2x by 6 minus secant 2x by 2 plus c. I repeat the whole process. Integral tan cube 2x into secant 2x dx is nothing but tan square 2x into secant 2x tan 2x dx can be written as integral secant square 2x minus 1, and derivative secant 2x is 2 secant 2x tan 2x dx. Multiply and divide by 2 anyway. Therefore this becomes half integral secant square 2x minus 1 d of secant 2x d of the quantity should be my substitution always. Half integral t square minus 1 dt where t is secant 2x, which gets reduced to half integral t square and half integral dt. That particular part I haven't written anyway. For t cube by 2 into 2 become 3 becomes 6 minus t by 2 plus c. For secant cube 2x by 6 minus secant 2x by 2 plus c is the final answer. That will be the final answer. It is not at all difficult to follow. Then question number 16 goes like this. Integral tan power 4x dx can be written as tan square x into tan square x dx can be written as tan square x into secant square x minus 1 dx can be written as tan square x into secant square x dx minus integral tan square x dx can be written as tan square x d of tan x minus integral secant square x minus 1 dx, which becomes integral t square dt minus integral secant square x dx plus integral dx ultimately, where replace what my t is. My t becomes automatically t becomes tan x, where t is equal to tan x. Therefore this becomes t cube by 3 minus tan x plus 6 plus c, which is anyway tan cube x by 3 minus tan x plus 6 plus c. That is the final answer. Let me just check the answer again. Integral tan power 4x dx can be written as integral tan square x into tan square x dx can be written as integral tan square x secant square x minus 1 dx can be written as integral tan square x secant square x dx minus integral tan square x dx, which is equal to integral tan square x into d of tan x is secant square x dx minus this written as secant square x minus 1 dx, which is integral t square dt minus integral secant square x dx minus into minus plus integral dx, where t is tan x. Integral t square dt is t cube by 3 minus tan x plus x plus c. Now for this gets reduced to tan cube x by 3 minus tan x plus x plus c. That is the final answer. It is not at all difficult to follow. Just recall how we go about it everywhere. Recall how we go about it everywhere. It is not at all difficult. It is not at all difficult to follow. It's easy for anybody to follow. It's easy for anybody to follow. Not a difficult thing to follow. Let me just rub this part to continue with the remaining problem. Let me think about 17. What happened to 17? Let us see. What is the 17th one? He says 17(1) integral sine cube x plus cos cube x divided by sine square x cos square x dx. Sine square x cos square x dx. Let me divide individually sine cube x by sine square x cos square x dx plus integral cos cube x dx by sine square x cos square x dx. Here on sine square x gets cancelled. Here on cos square x gets cancelled. Therefore this can be written as 1 by cos x into sin x by cos x dx plus integral 1 by sin x into cos x by sin x dx. This is nothing but secant x tan x dx plus integral cosecant x cot x dx, which is nothing but secant x minus cosecant x plus c. Let me just check whether my answer is right or wrong. Integral sine cube x plus cos cube x by sine square x plus cos square x dx. Divide individually. Integral sine cube x or sine square x cos square x dx plus integral cos cube x dx by sine square x cos square x dx. This is dx, sorry. This is dx Therefore, I cancel sine square x here, cos square x here. Therefore, I am just cancelling only the power. Power becomes 1. That's the meaning. I write it as 1 by cos x into sin x by cos x dx plus 1 by sin x into cos x by sin x dx. Just for the sake of convenience, I do like this so that it will be written as secant x tan x. Here it is cosecant x cot x. Integral secant x tan x is secant x. Integral cosecant x cot x is minus cosecant x, because derivative of secant x is secant x tan x. Derivative of cosecant x is anyway minus cosecant x cot x. Therefore, integral cosecant x cot x becomes minus cosecant x. It is not at all difficult to follow. Just understand. It's an easy thing. I'm making myself to make you understand the problems in an easier way. You need to give full attention to follow what is being done. Give full attention, you'll be able to follow. Question number 18. He says integral cos 2x plus 2 sin square x dx by cos square x. See here, this can be written as 1 minus 2 sin square x plus 2 sin square x dx divided by cos square x. This will get cancelled. This will reduce to integral secant square x dx, which is nothing but tan x plus c, which gets reduced to simply tan x plus c. It is not at all difficult to follow. I repeat the whole process. Integral cos 2x plus 2 sin square x dx. There are 4 different formulae for cos 2x. One is cos square x, cos 2a. It is cos square a minus sin square a. Other one is 2 cos square a minus 1. Third one is 1 minus 2 sin square a. Fourth one is 1 minus tan square by 1 plus tan square a. Here I am using the formula involving only sine. 1 minus 2 sin square x plus 2 sin square x. 2 sin square x gets cancelled. 1 by cos square x is nothing but secant square x. Integral secant square x is nothing but tan x plus c. It is nothing but tan x plus c. Anyway, it is almost 12 minutes, and I'll anyway continue with the rest in the next video. Thank you, students, for patient watching.